Welcome back. In this episode, we're diving into depressions, also known as low-pressure systems. These are key players in global weather patterns and often responsible for the most dynamic flying conditions. We'll explore how they form, what they look like, and what they mean for pilots. Let's start with the basics. A depression is a region of low atmospheric pressure. Air converges at the surface and rises, causing cloud formation, wind, and often precipitation. Because the air rises, it cools and condenses, forming cloud layers, especially stratiform and cumuliform clouds. That's why depressions are often linked with overcast skies, rain, and poor visibility. In the northern hemisphere, air flows inward and counterclockwise around a low. In the southern hemisphere, it flows inward and clockwise. This flow pattern creates wind shifts as you fly through or around the system. Let's talk about frontal depressions, which are common in mid-latitudes. These develop where warm and cold air masses meet. The warm air is lifted, forming a frontal system with a warm front, cold front, and sometimes an occlusion. Frontal depressions move generally west to east, following the jet stream. As they progress, they evolve through several stages, from initial formation to full development and eventual dissipation. The typical structure includes a warm sector between the fronts, a cold sector behind the cold front, a frontal zone ahead of the warm front. Each brings unique weather challenges for pilots. Flying into a depression, you'll first encounter the warm front. Expect high clouds, cirrus, altostratus, followed by nimbostratus, steady rain, and declining visibility. Icing is possible in these layers, especially between 0 degrees Celsius and minus 15 degrees Celsius. Next, the warm sector brings slightly better conditions, higher bases, scattered clouds, and possibly improved visibility. But don't relax, this sector is short-lived and can still include drizzle and low ceilings. Then comes the cold front, usually more dramatic. Expect towering cumulus or cumulonimbus, showers, gusty winds, and wind shear. These conditions are fast-moving and demand good situational awareness. Behind the cold front, conditions stabilize. Skies may clear, visibility improves, and pressure rises. But strong winds often remain, especially near the surface. This postfrontal air can be turbulent, especially near terrain. Let's break down the pressure profile. As the depression approaches, barometric pressure falls. Once the center passes, pressure rises sharply. Pilots must monitor QNH carefully to avoid errors in altimetry. This pressure dip also affects fuel planning and performance. Engines may behave differently in low-pressure zones. Add to that headwinds in certain quadrants, and you've got a complex en route challenge. Let's introduce the quadrant concept. A depression has 4 primary quadrants. Warm sector, between fronts. Cold sector, behind cold front. Frontal zone, ahead of warm front. Center or eye, lowest pressure. Each area has different wind, cloud, and visibility profiles. For example, the northwest quadrant of a northern hemisphere depression often has cold air, turbulence, and strong westerlies, tough for flying westbound. The southeast quadrant might have rain and low visibility in the warm sector. Some depressions become occluded, meaning the cold front catches up with the warm front, lifting warm air off the surface. This leads to complex cloud layers, embedded CBS, and challenging IFR conditions. Let's take a real-world example: you flying from Paris to Stockholm. A depression over Germany has just occluded. Expect layered cloud decks, patchy freezing rain, and embedded CBS. You brief for alternate routes and hold fuel in case of diversions. At lower levels, depressions can cause strong surface winds, especially in narrow isobar zones. Always check METARs for gust factors, and don't underestimate the effect of low-level wind shear on final approach. And don't forget the turbulence zones. These occur near frontal boundaries, in cloud layers, and especially when flying at lower levels through tight pressure gradients. Reduce speed to turbulence penetration settings when needed. Depressions are also linked with low-level jet streams, particularly near frontal surfaces. These can affect climb profiles and cause unexpected tailwinds or headwinds. Check wind charts and plan your climb strategy accordingly. Now, let's talk about decision-making. When a depression is forecast on your route, ask: where are the fronts and their timing? What altitudes have icing or turbulence? Are alternates in better air mass sectors? Do I have the fuel for deviation or holding? Depressions can shift quickly. Always check updated charts, TAFs, and satellite images during briefing and again just before departure. Stay flexible and don't lock into one strategy if the weather is changing. Let's wrap up with key takeaways. Depressions equals low pressure plus rising air equals cloud, wind, and precipitation. Frontal depressions have warm and cold sectors with unique flight challenges. Watch pressure changes and frontal timing. Use quadrant analysis for wind and turbulence expectations. Always monitor updates and plan alternate strategies. In the next episode, we'll continue with depressions, Part 2, where we'll cover development stages, occlusions, and how to fly smart when routing near or through active low-pressure systems. See you in Meteorology number 41, Depressions, Part 2.